Alright, welcome back, and in this particular video I'm going to talk about calculating the cost of electricity and comparing electrical appliances. So you're going to be going through an assignment here shortly to look at a variety of appliances and then determine the cost savings. So that's your goal. I can determine the cost of electricity and calculate the savings depending on my choice of products. Why is it important? Again, can't stress this enough. Saves money. This is why we are doing this particular unit. It's so that you're aware when you need to make large purchases that you make smart decisions. So I only have one example here. This is what you're going to be doing for all your appliances that you research. Appliance 1 uses on average 405 kilowatts a year. So we'll just list number 1. So we know that it uses 405 kilowatt hours per year. It's going to cost $2,099. So that's the range of a fridge, upper end washer dryer unit. So it could be a couple of appliances. Appliance number 2. It is cheaper in price, so $1,899. So you'd save $200, but it uses 675 kilowatt hours each year. So it uses a little bit more energy to function. So we have one that's efficient, one that's not as efficient. And this is always true. The more efficient your model, the higher the cost, because they've probably used better components or newer technology to bring that efficiency down. So if electricity costs 0.08 per kilowatt hour, determine which appliance is best if both are expected 10 years. So we're looking at a life expectancy of 10 years for these appliances, which is pretty reasonable, I would think, for many appliances. Microwaves, dishwashers, maybe not, but I would say fridges, washing machines, you should get that. So let's look at the first one. So the 405 kilowatt hours per year. So I guess I'll break it into steps again. So this is step 1, multiplied by 10 for 10 years. So that means you'd use 4,050 kilowatt hours. Step 2, you would take the total kilowatt hours, and we're going to multiply it by the cost per year, and we're using the 0.08 per year. So the 4,050 multiplied by 0.08, so $324, which doesn't seem too unreasonable over 10 years, only to cost you $324. So total cost of the appliance, you have to pay $2,099 today, and over the next 10 years, so $324. So that comes out to a total cost of $2,423 total. Or if you want to break it down per year, this appliance costs $242.30 per year. And that's over a 10-year span. Over 10 years. So it really depends on how you're looking at it. If you're kind of doing a payment system here, that you might want it in that form. If you're just going to pay everything up front or think of it as payment up front, then you're going to want it left as a total bulk cost there. So let's look at the second appliance, do the analysis there. So step 1, take the 675 kilowatt hours each year. Let's multiply it by 10 years. So that means that this appliance will use or consume 6,750 kilowatts. Step 2 is to take that amount, so kilowatts, and we're going to multiply this by the 8 cents. 8 cents, and I'm just going to go back over here. It shouldn't be per year, it should be kilowatt hour. I just did a typo. It doesn't really change our calculations at all. So 6750 times 0.08. So this one's going to cost $540 over the 10 years. So your total cost would equal, so this one cost $1,899 to purchase up front, plus it's going to cost you $540 to operate over the next couple of years. So this one comes out to 2,439. And if you break it down per year, so that would mean that over the 10 years, it's $243.90 per year over 10 years. So when you look at it, the two prices are actually pretty darn close. Total cost, if you look at 24.23 versus 24.39, we're only looking at a $16 difference. So actually, these two appliances are going to probably cost you the same over that time period. The difference is one's more energy efficient. So in this case, you really can't go wrong in which one you choose. However, that more high efficient one, if you can get discounts or some kind of rebate on it, then it becomes more and more viable. But you can see that if the energy difference here is almost $200, so that $200, it depends on that purchase price. So the second one costs more to operate, but in the long run, it costs almost the same. Does it work out this way the same always? Absolutely not. So this is an example just to show you. Most people are thinking, well, because he's got the other one with such a high kilowatt per hour up here, this is probably going to cost me more. Not always true. Sometimes when you're looking at if you can get appliance number 2 a lot cheaper than appliance 1, then paying that extra electrical cost is not so challenging or so difficult. So that finishes this particular section, and it's actually an assignment rather than homework. So we'll be working on investigating the different appliances that are out there and making comparisons. So good luck with that.